We are now at question 4 of this CXC CSEC May 2014 General Paper 2 exam video solution. And in this question 4, we are given a map of an island on a 1 centimeter grid, and we are told that the scale of the map is 1 to 50,000. That is, 1 unit on the map represents 50,000 units on the island. And the first part is asking us for the number of centimeters on the island, which is represented by 1 centimeter on the map. And so since our scale is 1 to 50,000, it means that 1 centimeter on the map would be equivalent to 50,000 centimeters on the island. And that's the answer for part 1. Now part 2 wants us to state the area on the island, which is represented by a 1 centimeter square area on the map. And since we have the scale, we can work from this calculation. Since 1 centimeter on the map is 50,000 centimeters on the island, we can square both sides of this relationship to see what 1 centimeter squared on the map would be equivalent to. And this is it. If we square both sides of this relationship, we will see that 1 centimeter squared on the map would therefore be equivalent to 50,000 centimeters all squared on the island. And now it's therefore just a matter of working out what this would be. And we can put it in a simple form by writing it such that this works out to be 1 centimeter squared on the map would now be equivalent to 5 times 10 to the 4th centimeters all squared on the island. And when we square the terms in this bracket, it becomes 25 multiplied by 10 to the 8th centimeters squared. Because if we square the 5, we get 25. We square 10 to the 4th, we get 10 to the 8th. And when we square the centimeters here, we get centimeters squared. And so 1 centimeter squared on the map would be equivalent to 25 times 10 to the 8th centimeters squared on the island. And to put it in standard form, this will become 2.5 times 10 to the 9 centimeters squared on the island. And so 1 centimeter squared on the map would be equivalent to 2.5 times 10 to the 9 centimeters squared on the island. And that's the answer for part 2. Part 3 now tells us that 1 kilometer is 100,000 centimeters. And we should know that. And we are now asked to state the number of kilometers on the island, which is represented by 1 centimeter on the map. And again, starting from what we know, that 1 centimeter on the map is 50,000 centimeters on the island. Since 1 kilometer is 100,000 centimeters, it means that 50,000 centimeters is half of a kilometer, or 0.5 kilometers. And so we can write that 1 centimeter on the map is therefore equivalent to 0.5 kilometers on the island. And that's the answer for part 3. And since we now have the relationship between centimeters on the map and kilometers on the island, we can look at area. We can note for area that 1 centimeter squared on the map would therefore be equivalent to 0.5 kilometers squared on the island. We are looking at the relationship now for area. And we get this relationship by squaring this relationship here. When we square both sides of this relationship, we end up with this. 1 centimeter all squared will therefore be equivalent to 0.5 kilometers all squared. And when we finalize that calculation, the 0.5 squared will give us 0.25 kilometers all squared. And so we now have the relationship for area. This is a relationship for distance, and now this is a relationship for area. 1 centimeter squared on the map is equivalent to 0.25 kilometers squared. This information we will need in the last part of this question. But let's move down now to part B. Now part B tells us that L and M on the map are 2 tracking stations. This is L and this is M. And the first part here wants us to state the distance LM on the map. And clearly the distance between L and M on the map is 1, 2, 3, 4, 5, 6, 7, 8 centimeters. Remember, each grid here is 1 centimeter. And so the distance between L and M is 8 centimeters. And so we can write that. and that's the answer. Part 2 now wants us to state the actual distance LM in kilometers on the island, and we can proceed by using the relationship that we already have, that 1 centimeter on the map is 0.5 kilometers on the island. And so if we want the equivalent distance for 8 centimeters, all we need to do is multiply this relationship by 8. And when we do that, we'll see that 8 centimeters on the map will be equivalent to 8 multiplied by 0.5 kilometers on the island. And that reduces to 4 kilometers on the island. We could also use the fact that 1 centimeter on the map represented 0.5 kilometers on the island. And so each grid would be equivalent to 0.5 kilometers. So we would have 0.51, 1.52, 2.53, 3.54. And so you could deduce that the actual distance between L and M on the island is 4 kilometers by counting grids on the map. In any case, the distance on the island between L and M is 4 kilometers. Let's move down now to part C. Part C now is bringing our attention to this forest reserve which is shaded, and we are asked now to estimate the area of the shaded region on the map by the method of counting squares. So we want to count the number of squares and estimate the area in this shaded region. And we will estimate the area by counting the number of whole squares and the number of half squares. So we see we have a number of whole squares here in the middle, and we have half squares at the edges, and we can mark those squares. So that's 1 square, 2 squares, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 whole squares in this area, and then we can count the half squares at the edges, and there are 1, 2, 3, 4, 5, 6 half squares. Remember that 1 square has an area of 1 centimeter squared, and so the estimate of the area on the map would be this: 12 whole squares plus 6 times half. That's 12 whole squares in green and 6 half squares. And when we do that calculation, the result is 15 centimeters squared. And so an estimate of the area of the shaded region is 15 centimeters squared. We could have also estimated the area by recognizing the shape of the shaded region. And if we observe, we'll see that the shaded region is approximately in the shape of a trapezium. And these are the dimensions of the trapezium. This side of the trapezium would be 8 centimeters long. This parallel side would be 2 centimeters long. And then the perpendicular distance between the parallel sides would be 3 centimeters. And so we could estimate the area of the forest region by recognizing that it is approximately the area of a trapezium. And we could do that. The estimate of the area shaded would be the area of the trapezium here, and the area of a trapezium is half the sum of the parallel sides multiplied by the distance between the parallel sides. And so this calculation would give us an estimate of the area shaded, and that also would give us a result of 15 centimeters squared. And so that would be the answer for part 1 of 4C. Let's move down now to part 2. And we now have that the area shaded on the map is 15 centimeters squared. And part 2 wants us to find the actual area of the forest. And we have to give our answer in kilometers squared. And from a previous section, we have the relationship between centimeters squared on the map and kilometers squared on the island. And this is it. 1 centimeter squared on the map was worked out to be equivalent to 0.25 kilometers squared on the island. And so if we want the equivalent area for 15 centimeters squared on the map, we simply multiply this relationship by 15. And this is it. When we multiply this relationship by 15, we end up having that 15 centimeters squared on the map is equivalent to 15 multiplied by 0.25 kilometers squared. and that works out to be 3.75 kilometers squared on the island. And so that is the answer. The actual area of the forest reserve is 3.75 kilometers squared because it is equivalent to the 15 centimeters squared on the map. And so that is the answer for part C of question 4, and that's the end of question 4. We'll do question 5 in the next video. See you then.